Testing audio, testing audio. And there we go. I think that managed to do it. Then we will head over to this screen, as so. And I believe we are live. Are you all able to hear me? The only thing I did not have was a professional microphone, so you'll have to do with my my laptop mic. Fantastic. Thank you, Rasmus, for confirming. Great. Then we'll get started. Hi, everyone, and welcome to today's Netcompany Virtual Tech Talk. My name is Sebastian, and I will be guiding you through today's topic, which is clean code. What we're talking about is this book, the topic that this book covers. More specifically, it's a book written by Robert C. Martin, which most of you probably know as Uncle Bob. I've basically just taken some chapters from this that I believe are very, very valuable and that you can learn a lot from in a very short time. So without further ado, I hope you've all gotten a cup of coffee or seated nicely. I think we'll just get started. To begin with, I would like you all just to take a brief 10 seconds to look at this code. Try to explain it to yourself, or go through what do you think this code does? What's the purpose of it? All right, so I'm gonna ask you again, what about this piece of code? Same thing. How would you explain this to someone? What do you think that it does? What's the purpose? How do you use this code? I'm gonna find the stream so I can actually answer any possible questions that you guys might have. There will also be time for questions in the end, but fire away. Excellent. So with those little exercises, I'm going to reveal to you that these two pieces of code actually does the same. It's the exact same piece of code. Now, on the left, I hope that most of you think that the code on the right side is much more readable and much more understandable than the code on the left. But really, all that we've been doing, excuse me for a second, there we go. Really, all that's done is just refactoring the code into something else. So in this case, for instance, we moved the condition in the if statement into the car class. We've also taken some sort of fuel tank class and wrapped that, meaning we can just call a function on that. And the same goes with this awful switch statement, made a specific function for that, right? So again, we refactored the code and we made it a lot more readable. And that's basically what clean code is to make sure that people are able to read and understand. So, I should mention this was to refuel a car, if anyone was still considering. So, the idea behind this is basically that as programmers, we are authors, and authors have readers. I don't have any specific numbers for it. In the book, they estimate that if you observed a programmer doing their work, you would see that around 9 times as much of their work would be reading other people's code, understanding what is already done, and only one of those, 9 times as much as just simply sitting and writing code. And if you establish that fact, you start to realize, well, then it will make sense to spend a little more time making sure that when we actually write code, we make sure it's readable for others, because they're going to spend a lot of time reading it, which means that making code easier to read also will make it easier to write. So, if you don't do this is what Robert believes will happen, and which I think many of us might might agree with. You start off very quickly, a lot of code is written, you're productive, you're feeling great, and over time your productivity simply decreases because making small adjustments, you're not sure if it goes as you want it to go. Maybe you break some code, you're uncertain about pieces of code that someone wrote months ago, years ago, and is that still valuable, right? So we want to make sure we keep our productivity at a certain level. And of course, clean code, it does take a little more time, right, to think about exactly what you're writing instead of just hacking away. And this is where you have a responsibility, I would say. You need to have the right attitude. I like the analogy that that he mentions in the book is if you were a patient, if you, let's say you were a doctor and you had a patient come to you, and the patient said, don't wash your hands, it doesn't matter, it's a waste of time, don't even bother. I believe that as a doctor you would still wash your hands because you know best, right? You know that even though the patient believes, it doesn't matter, you will still do it, right? And at the same, that's the same level that we should treat our code to either our co-workers or our clients or managers or whoever it is that believe, just do it quicker, don't worry about the quality. Because this is really, in long term, this is something that's going to benefit all of us. So what I'm going to talk to you today is basically what I've deemed a few tools from the Clean Code Toolbox. It's not really how it's mentioned in the book, but we're going to look a little bit about names, about functions and classes, how we use our comments, and then finally we're going to make sure that we write some tests for everything, right? And before we get into it, I'll leave you with this little rule. It's taken from, I believe, the American Boy Scout Association, or based around that. The idea is simply if you leave the code cleaner than you found it, you'll always go in the right direction, right? So if you see a piece of code that needs refactoring or needs to be cleaned, if you do that, if everyone would do that during their programming work or whatever they're doing, we'll slowly get to a point where all the code will be clean, right? So make sure you swear by that before you start coding. But without further ado, I think it's time to head off to our first topic, which is going to be meaningful names. Now, of course, we spend a lot of time giving names to stuff, right? We name classes, functions, variables, anything can pretty much, so much time is spent on names. And that's why it would be a nice idea to actually use proper naming. So, first of all, I would like to say that refactoring is going to be a big part of what I'm talking today, and I hope you are not afraid to refactor. If you find something that doesn't look right, please change it, because otherwise it'll stay wrong forever, right? So we should be able to make sure we make good names, we refactor existing names, and a name should always try to tell you, first of all, why it exists, what it is, what it does, and how it's used. Okay, because the code should kind of be explicit by nature, right? So on the example of the right here, I have a variable called d, and now I've written a comment called elapsed time in days, and that kind of gives me an understanding of what is the purpose of this variable, right? But I could also just call the variable elapsed time in days, and no matter what, I'll always know what that variable what's the intention of it, right? What does it measure? I even know that this is measured in days, right? It provides me with a huge advantage, and we're going to look into comments later on and see why maybe we won't use that as much as we would like. Yes, so make sure you use intention revealing names, right? Similarly, avoid disinformation. If you name something a list, make sure it's actually a list, and best of all, don't call it a list, because you could also change the data structure and all of a sudden it's not a list anymore, right? Be consistent in your spelling and try to avoid abbreviations. Here I have a variable called HP. I would like for you all to take a guess on what you think that might be. I've heard a wide variety of suggestions for this. Some may think health points. From this example, it was actually the hypotenuse, the longest side of the triangle with a 90-degree angle. Wow. There's some math there that I haven't practiced in a while. Anyway, yeah, and finally, don't use lowercase l or uppercase o for variables, because it's difficult to see. Is it a 1? Is it an L? Is it an O? Is it a 0? Right? Very simple. Stay by these rules, believe me. We want to use pronounceable and searchable names so we can talk about our code with our co-workers, with our fellow peers. As you can see here on the right, we have examples of names that are not so easy to pronounce. And then we also want to make searchable names, because if we have a code base of 20,000, 200,000 lines, it would be great if not everything was named I, right? So in the bottom you can see here, instead of using I use max at once or account index. In this case, right, would make it much more searchable. Class names, classes, they should be nouns like customer, account, address, parser. You should avoid stuff like manager, processor, data, info, because those are kind of ambiguous, and unless you really agree that like what is a manager, don't use that. Make sure class names, they should not be verbs, okay? On the other hand, method names or functions, they should be verbs. Should be verbs like post payment, delete page, or save, because it's something we do, it's a function, right? So also suggest that you use get, set, and is according to the standard. In this case, you can use like get name or set salary or is currently employed, right? You would kind of expect them to you can kind of see just from the function name what they do, right? So try to stick to class names being nouns and method names to be function names to be verbs, right? Excellent. Then programmer languages, or programmer language, I should say. Remember that the code is read by programmers, right? So don't be afraid to use technical names for well-known concepts, such as specific names for algorithms, right? Dijkstra's shortest path, you kind of immediately know, okay, what's the algorithm behind this? You don't even have to look at it. Twitter-like adapter, if you use any patterns, you know, like design patterns here, it's an adapter. Please add that to the name. People will know, people will kind of, you can start to quickly see like, okay, this is the design pattern we all care and love, and now I don't have to read more into it. Of the data structure, as I mentioned, right? An event queue would be great if you're actually using a queue, for instance. And then finally, you can do something with meaningful context. Basically, what that just means is, instead of having long classes with thousands of variables, you can group variables put together, and by proper naming them, you can kind of give even more information, right? So in this case, for instance, a state, that can be both read as a state is in an address, or it could be a state as in an element, right? Water can be solid or gas or liquid. But by wrapping those names in another class and calling that address or element, for instance, will kind of provide you more information about it. So that's a little bit about names. I think this is just a starting point and something you'll learn the more you kind of practice it. I should also probably state at this point, the code I show you can be kind of all over the place. Some of it is Java, some of it is Groovy, some of it is C#, but there's no real like magic behind it. Just take it as it is, and yeah, probably won't compile until we get to the actual coding part. So it's just to make sure that everyone can kind of get an understanding. Okay, so next up we're going to look a bit at functions. Okay, now a function should be this. And by this I mean a function should be small, okay? And when you think a function is small, you should make it even smaller, all right? I'll give you examples here on this. So for instance, the conditions for if, else, and while, you should wrap that in a function. On the right here we have a check here, if index modulo 2 equals 0, then we do something, right? I wrap that statement, I wrap that condition in a function, and I call the function isNumberEven. By that, you will never have to worry about what's inside of that function, because you know that the function checks if a certain number is even, right? And you kind of get this fantastic like prose kind of way of reading code. Like you won't have to deal with all sorts of Boolean checks and such. You can kind of just read it in a whole sentence. It's beautiful. Similarly, the blocks within the if, else, while statement should also be functions, right? So in this example, instead of defining corn and adding it to a basket, then go to checkout and pay, I wrap that entire, in those 4 lines of code into a single function, right? Add corn to basket and pay. So again, as I said, the pros text kind of come out, right? If I should buy corn, then I add the corn to basket and pay. And I don't have to worry about the underlying code, because of course, I mean, my coworkers have written this. They write proper code and they test it, so I know it works. And I can easily understand it without having to read more than a function name, right? In terms of indentations, we want to aim at not going greater than 1 or 2. So in this case, for instance, you have a while statement, and inside the while statement you have an if statement and an else statement. That's kind of like the limit where we want to go. If you then have an if statement inside that if statement, and then a loop inside that, and a third if statement, the code becomes, I mean, pretty, first of all, very difficult to test because there's so many scenarios. But it's also impossible to figure out when you're in a certain in a certain scope and not. So instead, you can see here I wrap the inside of the while function in a different function, the while loop in a different function called countdown, and then I don't have to go as far in from the left. Now, and this is very, very important, functions should only do one thing, okay? It should stick to one level of abstraction, and it's a very fuzzy topic to talk about. It's difficult to exactly say what is one thing. But in this case, for instance, we have a program that's run, and we print stuff, we connect to a database, we select a user, we then print the user, and then we disconnect again. But instead, if we took that, okay, so what's the overall thing? Well, first of all, we set up, and then we do something, and then we close the connection. Well, by wrapping functions and making sure that functions only do one thing, it's easy to reuse those functions. By having a function close connections, right, I can make sure that no matter where I call it, I'll only have to worry about that function closing the connections. I won't have to think about, oh, but then that function also prints a user, so that's not so good to use here. So try to make sure that each function only has one purpose, or one level of abstraction, I should say. Because of course you're going to have to wrap stuff, right, in outer scopes, like outer functions and further down. Just making sure we have everything good with the YouTube stream here. Have way too many windows open. I need a second screen, a third screen, I should say. I'm already running at FU. There we go. Now I can actually see what you guys are writing. If I do this, there we go. Excellent. So, switch statements. Given that I just told you that functions should only do one thing, switch statements turns out to be a mess. Switch statements, when I first counted them, I thought they were beautiful. I thought they were a great way to not have these long if else, if else, if else. But switch statements kind of signify that, well, obviously you are doing more than one thing in this function, right? So instead, what you do is simply you hide it by using polymorphism. I don't have time to go into that today, I think. So if you want further, if you're not aware of the factory pattern, you can go read on it. But simply on the right, for instance, the problem is that if I have some sort of employee with a type, right? I have a professor type and I have a teaching assistant type. Now, every time that those two types differ in their functionality, for instance, when we have to pay them, or when we have to figure out how many classes they should teach or something, we'll have to make a switch statement, and that'll end up maybe showing up 20, 30, 40 times in the code. And every time we extend the functionality with a new type, we'll have to change that 40 times in the code. So instead, you want to wrap it so that you're using an abstract class, and then using subclasses from that. So, for instance, one class would be professor, one class would be teaching assistant, which both inherits from employee type, and then you can have the individual behavior in there. Again, if you don't know of it, read on the factory pattern, and I hope it'll give you a bit more understanding of what this is. Excellent. So we're going to talk a bit about function arguments. I'm not going to try to pronounce these terms on the left, but basically want to try to as few arguments as possible. The problem is that an argument kind of forces a reader to know about a function, right? Every parameter in a function is an information that you should pass in, right? So the fewer arguments mean that it's easier to test because fewer combinations exist and it's easier to use it, right? So in this case, beer.isEmpty, you don't have to provide any information for that. It's great. You can call that and you kind of know it, right? For monadic and dyadic like functions, pretty good still, but I think usually when we come down to around 3 arguments, you should consider doing something else, refactoring the code. And then finally, you want to use return values instead of just modifying arguments. So if I have a function that takes in a list, I want to make sure I return a list as well in the end, and not just modify the list and expect the reader to kind of know that that has now been modified. Flag arguments, okay, these are Boolean arguments. They should be avoided because it obviously shows that the function is doing more than one thing, right? If I have a Boolean called post to Facebook, kind of shows me that this function will either post to Facebook or not. That's 2 things, and a function should only have one purpose, okay? So if you have those, consider moving that into 2 separate functions, definitely. And don't forget that it's okay to wrap several arguments in a class. On the right side, you can see an example from anyone who's done any game development. Usually you have a vector3 class, so you have 3 floats for x, y, z coordinates instead of having literally passing in those 3 arguments all the time. So don't be afraid to wrap arguments if needed. And then finally, try to avoid side effects. It means that maybe you'll couple code at unnecessary points and you'll have code that is uncallable. For instance, if you're initializing a session in a function, then you'll have to remember that when you call that function, a session needs to be initialized as well. So try to avoid side effects and make sure you don't repeat yourself, of course. I think this is how most of us learn how to use functions in the beginning. Code duplication should of course be avoided also in test, and I want to say unless it makes sense, because sometimes for readability purposes it's okay to have code show up more than once instead of making these obscure spaghetti code that's like, oh, but nothing appears more than once. Then it's better to aim for readability. Let's see how we're doing on time. I think I am good so far. Alright, so briefly, classes. This is a class. Classes should also be small, similar to functions. There's simply too much to say about how we structure classes, but I would like to suggest that you go and read up on the solid principles if you don't know them. If you do know them, at least go and look at the S and the O, the single responsibility pattern and the open-closed principle. Single responsibility principle and the open-closed principle, because they're going to do you a lot of good things if you understand them and know how to use them. But unfortunately, we won't really have time to cover that today. So if you remember anything from this, remember this image and remember that this is a function and this is a class. That's the most important thing. Small classes, small functions. Makes modularity and reusability very much easier to achieve. Alright, we're going to move on to comments, and while I have a little bit of coffee, I'm going to ask you this. Why do you think we need comments, alright? Why do we need comments? Think about that for a second. Now, comments, the fact is that we don't need comments, alright? Comments are kind of a necessary evil, right? When we use a comment, it's because we couldn't express ourselves in the code. We should see this as a failure, all right? Comments are not easy to maintain, all right? They don't follow the code. If I refactor a variable that in an IDE, that variable will change all over the code. The comment that I've written will not follow around, and you won't be able to see it from other classes if you're calling it, right? If you're looking into it. So if you think to yourself, here I should write a comment, try try to avoid it. Don't fix bad code with a comment. Try to clean it instead. Make sure the code is readable by itself. So yeah, whenever you write a comment, please reconsider. In this case, we have an if statement here and a comment that says check if eligible for benefits. Now the problem is I won't be able to see inside of this if statement from other classes or other functions unless I go to that actual if statement, or so to speak. The bottom part is immensely more easy to follow, and you immediately know what this piece of code does, right? You immediately know that this if statement checks if an employee is eligible for benefits, and it'll be much easier to use in other classes as well, right? In other functions as well, because the employee you can just call is eligible for benefits instead of having these checks all around the code. I could spend a long time doing this, so I'll briefly go through it. We're going to look at a few good comments and a few bad comments. First of all, good comments. Legal comments, they exist. For instance, you have to, for copyright issues, for copyright statements or something, usually we would suggest simply referring to a file, an external document in the comments, so that way you won't have to update it all the time. Then you can just update that single file, right? There are informative comments and clarification. Things like regex patterns can be, for some of us at least, quite difficult to read just from looking at it. Or if you have something like in the bottom here, compare to A is equal to 1. What does that exactly mean? Well, in this case it means that B is greater than A. So you can use comments when for clarification, right? If it's really obscure what the code is trying to tell you here. For warnings, for instance, if there's something that you really don't want people to do and there's a specific reason for it, you can add that. Or in this case, if an external API, something you don't really have control over, you can add a little text to say, okay, hey, by the way, we're doing this. I know it sounds crazy, but we're doing it for this reason. And finally, JavaDoc, right? Or anything that's basically a public API, any documentation that follows with a public API, you should definitely add documentation, right? JavaDoc is just one form of it. Some bad comments then, redundant comments, right? This is what is simply just going to clutter your code. Public car, the default constructor. I think most of us will know that. We don't need to specify that, right? Call a float height, and then add a comment that says this is the height, right? Not necessary. If we name our variables correctly, we don't need to add these comments. Methods, right? Get last name. What? No way. That's not. That actually returns the last name. I would have no idea. Trying to be sarcastic here. Of course, we we know exactly what this function does, right? Commented out code. People won't know why it was commented out, why it's not used anymore. If it's not used, delete it, and you can always retrieve it. Most of us use version control systems such as Git, right? You can always retrieve that code later. This will simply just show up 3 years later, and someone will look at it and say, I wonder why this is not used anymore. Should we delete it? Can I delete it? Is it important? I don't know. Mumbling comments. If you do take time to actually write a comment, please use at least the time to make a proper comment, okay? This one doesn't happen unless the old implementation is being tested. People who come across this will have no idea what you meant, and they don't know what the old implementation even means. Maybe it was something that was written 2 years ago. So if you do make comments, please spend time on making them informative. And finally, journal comments. I rarely see these, but they do show up sometimes. I don't think it's necessary to put in your name in your code. Most IDEs will also have an annotate function where you can simply see line by line who made the recent changes to this code, so you won't need to put your name on it or any changes that are made. Again, it's stuff like Git is gonna help you keep track of it, right? And misleading comments. I think this is my favorite. Sometimes you can write a comment. See the first here measured in Celsius, but if it's not correct, people will just assume it, but the temperature might actually be measured in something differently, right? Or in the bottom part here, maybe we swapped this function around, but we forgot to update the comment. And now, when people use the compare function, they'll believe it returns true when the value is smaller than the input, but it actually does the opposite, which can lead to frustration among people who are using this, right? And I end with this little story for those of you who don't know. The Mars Climate Orbiter that NASA sent to Mars. The reason why this didn't work, or why the orbiter crashed on impact, was that the software calculated the force, the thrusters needed to exert in pounds of force, and a separate piece of software took in the data assuming it was in the metric unit, newtons. I'm not saying this was due to a bad comment or someone not naming their variables well, right? But it just shows how expensive it can be if you don't think about what you name your things. And if you just simply named it force in newtons, or put that in your public API documentation, I'm pretty sure people would make sure that they used it correctly. We're going to skip this discussion since we're on YouTube. To do comments, everyone has different opinions, but I usually find these to be written and then forgotten about, and kind of similar to commented out code. If you don't, if you do write these, try to make sure to at least keep them up to date. And again, IDEs have functions where you can simply find all the to-dos and make sure that a build can complete if you have any to-do functions, to-do statements or something like that. Yes. Now to the exciting part. Unit tests. All right. This is where we're also going to look at some code, and I'm going to put myself out there, and we'll see how that goes. This is an interesting question. So what is the purpose of automated tests, you think, right? Automated being the key word here. And there can be many different answers to this, of course. I think many would say, well, it's to make sure our code works, which is partly true. But to be honest, we could all just test our code manually, functional test, and say, yes, it works. And that's why I think what we need to add here is that automated tests make sure that our code can that's a word I can't even say, can be tested again and again and again in a very short amount of time, right? So we can repeat the tests for infinite times without having to sit down, start up our application, click through every single scenario that we wanted to test, right? And of course, clean code also includes clean tests. And in the clean code universe, we're going to lean up against this this test-driven development approach. And Robert actually suggests he suggests these three laws of test-driven development, which are, you can adhere to them very strictly, or you can, at least go with the idea of writing tests before we write our production code. But the three laws of test-driven development basically say this: you may not write production code until you have written a failing unit test. And failing in this case is also not compiling. That's a failing unit test. You may not write more of a unit test than is sufficient to fail. And as I said, not compiling is failing. And you may not write more production code than is sufficient to pass the currently failing test. What this does is that we get into this loop where infinite loop of writing a test, then writing the production code, and then refactoring that code again. And you keep going through this iterative process until you end up with a production code that you not only know works because you have tests for it, but you also have a complete test suite that you can run again and again and again. So in the future, when people make changes to the code, they don't have to worry about breaking something you've made. And that's the whole purpose of this TDD. We put up this exercise when you signed up at the end of the form, I believe, to get the link. Write a program or a piece of code which prints all prime numbers up to a given input n, ordered from lowest to highest number. So I had an input-output table as well. And I'm going to try to go through this using TestDriven Development. We're going to use this. I'm going to do it in Groovy, which is compiles to Java. So it's basically, I would say, Java but small, Java but smart. It's kind of the C# of Java. Unless you hate C#, then it's not C# of Java. But it's very similar to Java in terms of the syntax. The only difference is you don't do, I would say, at least one of the biggest differences is that you don't have semicolons. So before you start commenting out that I'm missing stuff, don't worry about it. Semicolons are not used. Yes. So without further ado, we're going to try to jump into this live demo. And yes, I hope you can all see the IntelliJ IDE at this point. If not, I've done something wrong, but it looks like it's working. Okay, so to write my test here, I have a test set up already. I named it Prime Printer Spec. I've added prime numbers from 1 to 150. That's just to verify that I actually used the correct data. I cheated and found it online. And then we're going to use a framework called Spock. Don't need to... yes, excellent, bigger font. I tried to increase it earlier. I did not know if it was enough. That should... If you need it bigger as well, let me know. It's mainly just so you can see more lines on the screen, but I can always enlarge it. Actually, let's just do that right away to make sure that those of us who don't have the sharpest eyes are actually able to see what's going on. All right. Hope that is better. See? That seems good. Thank you very much. Excellent, thanks. Okay, so Spock, it's a testing framework. Don't worry too much about it. What we only need to know is that it follows what we called an arrange, act, and assert pattern. That's how we structure our test. So we start by arranging, setting up the test. We do some sort of functionality. I wish I could control scroll to change text size. I do not remember how it's done in IntelliJ, but I'm sure there is one way or another. Yes. So arrange, act, assert. You set up your test, you act on it, and then you make sure that that things are as they're expected to. And in Spock, it looks like this. You're gonna have a given block in which you can put any sort of code in. You're gonna follow that with a when block. This is our what we called our act, and then we have a then block, and that's basically just how we set up our code in Spock. And so I can set up my my code here. So that's how Spock works, and let's get right into it. So for print primes, in this case, everything works as far as we know. All I've done here is make a test that's called print primes. And to begin with, well, we'll start up by setting up the test. In this case, we're going to have a printer, some sort of printer, and we're going to call that a new prime printer. And as you can see here, we have a problem. Code turns red. The code doesn't compile. Already here, we're breaking the first rule, or the second rule, so to speak. We reached a point where the code doesn't compile. Therefore, we can now go on and write production code. I'm going to cheat. I'm going to use the IDE here, a shortcut into creating a new class called prime printer. We're going to throw that in here. And now we have our class prime printer. We'll go back, check our printer spec. The test looks fine. It compiles again. We're not allowed to write any more code according to the laws of TDD, production code. So now we can continue writing on that test, right? So now we have a prime printer. Okay, that should be enough for a test. Well, we're gonna do something too. We're gonna say when the printer, actually we're gonna say we're gonna have a string. We're gonna call that expected printed result, I should say. And we're gonna say that's what happens when you say printer dot print primes. okay, we have a problem here, right? Code does not compile. It does not know what this print prime is. So we'll go in, we'll make sure we have a method in there that's called print primes in our print primes, in our prime printer. Wow, a lot of P's here. And now we've added that to our class. We'll go back. You can see the code now compiles. That's great. We're allowed to write more on our test. We're going to put in a number here. We're going to call print primes, let's say 4. 4 is between 2 and 3. And we again see that, okay, there's a problem. We are not allowed to call this function with an argument. So we're going to go in and add that to our little function here. That's it. We go back to our test. See everything's working fine. And we're going to continue on to our assert pattern, right? So again, so far I've strictly adhered to the whole idea of we write our test until it fails or doesn't compile. Then we write production code until the test does compile or runs correctly. And then we simply just continue, right? And finally, we're going to say, well, we expect the printed result to be equal to, I'm going to say 2, 3 in this case. Okay, the test compiles, that's good. Our production code compiles as well. I'm going to try to run this printer spec for a second. See if we have any. Excellent. So, going to start up here. Second, we can instantiate the tests. See if it works. Nope, we have an error here. Of course we do. Our assert fails, right? The printed result simply returns null. So I could go in here. I could say, well, no matter what you give me, I can return 2 plus 3. And I could go ahead and run the test again. And we're good. And that basically means that we are now back to our test, right? And I can, of course, I could go ahead and say, well, now we know at least that our print primes, that gives us the right result when we ask on the max prime number 4. And I could copy this function and I could make multiple tests for this and do with different different inputs. But I'm going to use a little thing in Spock called DataDriven Testing, basically using something called data tables. What you're able to do is give a list of, say, inputs to each test, which simply means you can run the test multiple times with different inputs. So in this case, I'm going to say we're going to have one parameter called max prime. I'm going to have one parameter called expected result. In this case, if our max prime is 4, we're going to expect a result of 2, 3. And then I can use these parameters in my test instead of the hard-coded values, and I can rerun the test. And the good thing about this, as we'll see in a second, is this builds. Having streaming software open, I think, kills a little bit of my my computer's power performance. We run the test again, it runs fine. But the beauty of this is I can now extend the test data simply by adding new inputs. So in this case, for instance, I gotta say, well, if we give it a 7, I would expect a 2, a 3, a 5, and a 7. And to help you out here, I'm gonna use a little annotation here to roll the test. And now, when I run the test, I'll actually be able to, I'm sorry if the font down here is very small. I hope you can at least see that it's green. But now when I run the test, I'll actually be able to run it multiple times. It'll run once for my first input and a second time for my second input. We have a problem though. The second input does not satisfy our assert pattern, right? And that's of course because our prime printer prime printer did not fulfill its needs, right? It's just returning 2, 3 all the time. So I can go in now that our test is failing, and I can extend this lovely function to accommodate these two And otherwise, actually we're just going to do an else. We're going to return 2, 3, 5, 7 like that. So again, we write a test, the test fails, we write production code, the test clears, we can write more tests. And this would in theory be enough to see I've done something. That's because I used another. I used 4, sorry, as my input here. And we'll run this test again, and we can of course repeat this multiple times, right? Now the interesting part, of course, becomes at what point do you stop this? I have these two situations that works fine. But then what if I, for instance, say now we also want to see what happens if I add a 3? I would still expect 2 and 3, right? And the test will fail in this case, and I go in here and I could add another if statement. But we don't really want to do that because it is, yeah, that's where we kind of like refactor the code and realize this is not an efficient way of doing it, right? And that's where, of course, we would go in and we would write the actual functionality to do the entire code. I'm going to cheat a little bit here to save some time. I have this ready. It's actually going to tell me I have duplicated code because I have this other place in the project. Here's what we do. We are gonna quickly just go through this method. The method simply just starts with a string, then it goes through each of our the idea behind the algorithm is basically just okay, we are looking at every single prime number or every single number up to this max prime. We're going to check if that's a prime number, and if it is, we're going to print it. And how we're going to check that's basically what we're doing here. And how we're going to check that is by, when I'm looking at a number, I'm going to take every number less than that. So for instance, if I'm looking at the number 4 and investigating, is this a prime number? I'm going to start off with the number 3. I'm going to check, is 4 modulo 3 0? This is basically the check for to say like, okay, is this divided by, is this divided by the second number and equals. I hope you know how this works, because I can barely explain it. And if that's the case, then we add the number of kind of numbers that add up to this, that can be multiplied to add up to this, right? And for prime numbers, the deal is that if there are only 2 multiples, that means the number 1 and the actual number itself, for instance 17, then we add it as a prime number. And in the end, we trim this wonderful thing. And so I'm just going to quickly run this test again. Now that we've updated it, it should give us the proper results. And you can see that it actually runs through and does everything, right? And at this point as well, I would of course say, okay, how is my code looking? Is this what I would call clean code? I think it's, you can see I had trouble even explaining it to you. So I would probably do something else. I would refactor the code instead, and I would pull out into smaller function. I'll quickly try to do that before we end today's section. Sorry about the lag. I'll try to slow down a little bit. So for instance, instead of doing this thing, this is a big function, right? This is basically just a function that checks if a number is a prime number, right? So that would be perfect if we simply just remove that into a separate function. In this case, I'll make a bool function. Let's call this prime. We'll give that a number. And we're simply going to move our little bit of code in here. And we're going to take this little snippet here. And I am going to return. There we go. So, I think we can actually just do. Oh, there's something wonderful here. Let's see again. We're gonna call this number, and we are gonna. Now we're gonna swap that around. We're gonna do like that. Sorry. So this is our isPrime function. It says how many multiples have we found. We run through every number less than the number we are currently investigating. We make our check here if this could probably be extracted into a function as well, right? If the modulo condition is 0, we add that to the amount of multiples, and we simply just return amount of found multiples. And this would, for instance, be a good case, I would say, to add a comment like this. So if exactly 2 multiples are found, it's a prime. That's like the condition of the prime, right? So now that we have that, we can kind of remove all of this awful code, and instead we'll simply call our function isPrime. It can be the investigated number. So we'll check if this number is prime, and if it is, we're going to add it to our string and add a little bit of space here in the end. Added a comment here as instance, appended the prime number to the string in case people are not sure what it's doing. Could be an idea. Maybe it's probably, I would say, an unnecessary code. We could probably shorten it to do something like this, which might be easier for people. We could maybe add a comment down here in case people are wondering why are we trimming this string, why is that necessary? Well, due to my code, there's added an extra space in the end. We could go even further. I think I'm just briefly going to do that by, instead of having both this function print the primes and find the primes, we're going to separate it. Sven is saying there is a polishing, brushing sound that goes into the microphone. Might be the neighbors. I'll try to move less. Maybe it's me. So this would be, of course, one way to doing it. Instead, I think we're gonna make a different function as well. So our print primes function is simply gonna take in, let's say, a series of prime numbers. We're just gonna call a number called find primes, and we're gonna say we're gonna do that up to the max number of primes. And we're gonna we'll call this one prime text instead. And then for all our numbers, we're gonna go through each of them, and we are simply going to, I'm cheating a little bit here and looking at my cheat sheet. We're gonna add that, and we're gonna add the little space, and in the end we're gonna trim it. There we go. So if I remove this, you can see our print primes function has been shorted significantly. I think it's much more readable as well. We find the primes, then we go through each of the prime numbers, and we simply add the prime to the prime text, and then we return that, right? And then, of course, for this we would need a method to actually find the prime numbers, which we're gonna highest prime, which we're gonna add here, and that will simply just be what we had before. We're gonna write it out. Found primes equals, and for this case, let's say we have a thing we call investigated number. So that's, let's say we have, yeah, if I don't know if investigated number is a good number. We'll start with 1, say this is the first number, we'll investigate and figure out if it is a prime. As long as it's less than or equal to the highest prime, we're gonna loop through this and say plus plus. Due to the large font size, you guys are unable to read this, unfortunately, but I trust you kind of know how it works. And then in this case, I actually just gonna look if the investigated number is a prime number. Well, we're gonna add that to our list of primes, to our found primes, and in the end we're gonna return found primes. Okay, so this would be kind of a way to refactoring based on what I would say the clean code principles, right? We have a large function that did a lot of stuff. Not only did it print all the primes, it also found all the primes, and it also defined whether or not a number was a prime. Instead, we split that up, so now we have a single function which checks is something a prime. That'll be useful. We can use that pretty much in anything now. We have another function that is called find primes up to the highest prime, which we can also reuse multiple times. Maybe we just want to know them. Maybe we don't want to print them. And then we finally have a printer that changes the way we print stuff. So, for instance, I could add a comma to separate the strings in a different way. And the point of all this is, of course, that because we've used TDD, we have a test suite, or a test, I should say, that already shows us that everything works. This, we knew beforehand that this test proved the correct behavior. And so, even after doing all the crazy refactoring I just did, I can simply run the test again, and I don't have to be afraid if I broke anything, because obviously the tests will tell me if I broke anything, right? And there we go. I'm briefly gonna. One of the beautiful things that's not part of TDD at all, but one of the beautiful things about Spock, in case some of you are writing in Java, is that you can actually use these parameters in your test names as well. So in this case, I can throw them in the name of the test, and when I run it, due to this unroll annotation, they'll actually show up here in a second, using those individual inputs I gave it. In this case, the test will name printing until 3 gives result 2.3, printing until 4 gives result 2.3, and so on and so on. I think that was very fast, I'll admit that. But I hope it kind of gave you an idea of how TDD can work, right? Of course, are you following this down to the... And you can use prime numbers.join to join them to a space-separated string. That would be a great way to avoid our trim in the end, right? So Gregers, I know the moment you see this code and you come across it and you see this little line, you say, that's stupid, Sebastian. Why did you do that? You can go ahead and change it, and you can run my tests, and you won't have to worry about if you broke anything. I think that's a great example of how you can do it. All right, so this was TDD, and you can follow it very strictly. You can also follow it to the path to the degree of where you at least write your tests before you write your production code, which I think is generally a good idea, because then you also define your intended behavior before you start touching your logic, right? It's always good to have a clear understanding of what is the intended use of this code and what do you actually want to achieve. Finally, we'll go back to that was the kind of live coding portion. I hope it was somewhat. It didn't go too terribly. It's always kind of nerve-wracking to go on screen and try to code live, but I think it went okay. So thanks for sticking with me. In terms of tests, I would suggest you aim for FIRST, an acronym used for fast, independent, repeatable, self-validating, and timely. You can find this probably online easily. The goal here simply being that if some of the pitfalls we've seen is that if tests take 20 minutes to run, you're not going to run them often, and you're not going to be able to do this TDD efficiently, right? And then people strive away from it. If there are any questions for unit testing in general, for unit testing specifically, I think we'll feel free to ask them now before we go to the outro, and there'll be time for questions in the end as well. I pretty much almost stuck to the time limit for once. So, fire away. I hope you guys can manage to listen to me just another 5 minutes or so. That's pretty much all I have left. In the end, what did we cover today in this brief hour? Very brief hour. We looked a little bit at meaningful names. What names should we use in our code to make sure that other people can read and understand it quickly? We understood that functions and classes should be small, simply for functionality, for modularity and reusability. We tried to make sure that we don't write comments unless it is completely necessary and there's no other way to go around it. And then we also learned how to back our production code with a test suite using TDD. One thing that's also very important in terms of TDD, and one that you probably won't know until you've been in a situation where you meet code that is untestable, is that by writing your tests first, you also ensure that your tests are actually testable. That's a very, very good point, especially if you work with legacy code and try to find code that's 15 years old and you're asked to do test on it. If you were sit there and say, well, simply this code is untestable, I have to refactor it. And since you can't write tests, and if there are no existing tests, there's no way of verifying that you didn't break anything, right? And that's also why it's such a good idea to start with the tests. Some of the chapters that wasn't covered or mentioned today, as I said, it was just a brief portion of the Clean Code Handbook. You can see here. I use I would say formatting. I usually tend to include as well if I do this presentation, but most IDEs are able to do that. You can put up setups like CodeNarc or SonarQube to simply just look at your code, static code analysis, and inform you if you've done anything wrong, right? So you don't have to worry about that too much. And something like error handling is mainly just use exceptions. So if you don't know anything about exceptions, go ahead and read up on that. The rest of them are, I would say, a bit more, a bit deeper down. Takes a little bit more coding knowledge. I think one of the beautiful things about what we covered today is that it should be usable in pretty much any language. Primarily object-oriented, of course, but even, it doesn't matter if you're writing Java or Python or C#. I think what you learned today is pretty valid in all of these languages. There is also some super Java-specific stuff, like for instance JUnit. And then the final chapter, the chapter 17, is actually just a long list of smells and heuristics, as you call them, like indications that the code is in a bad state, which can be an interesting thing to go through. At least try to look at it, right? To just like check if this is true, then probably we should refactor it. Awesome. Further readings, Solid Principles, as I mentioned. Uncle Bob has also written, I don't know if we want to call it a sequel, a clean architecture, which is, again, goes a little bit deeper into the overall architecture instead of the specific code. I haven't read it, but I believe it's also a good read. Refactoring by Martin Fowler should also be a good one if you want to continue. There are plenty of materials on this on YouTube. I've seen people do clean code talks on even front end stuff like how you write clean CSS and JavaScript. And finally, I would suggest to discuss with your peers if they are co-workers or co-students or just friends. I think that's the best way to learn. Discuss what you think, what you believe, and talk with others. Be open about why they do one thing and why you might do another, and try to learn from each other. If you want more, go check this kata out if you're into Codekata's code assignments. Gilded Rose, it's called. You can find it online. There are Git repos which have them in pretty much any language. It's a good exercise for refactoring legacy code if you want to try it out and try to exercise some of the things we mentioned today. And maybe if you did the exercise that was in the sign-up formula, you can try to refactor the code you produced there, which could be an interesting way of seeing if that changes, right? Like if today, what did you learn? Would you have done it differently? If you want more, as I said in the beginning, I'm a consultant for Netcompany, and by that we do a lot of stuff. We have the joy of working with a lot of different technologies and a lot of different frameworks and such. Here are some of the things that I've touched upon over the last year. Some Kubernetes, anything related to Grails pretty much, and a bit of Jenkins as well, for instance. I went online on our internal Stack Overflow, as I would call it, and looked back in February when I first made this presentation, what people had been working on. And I found some of these things that is also out there that my colleagues have been interested in: Vue, Kafka, React, .NET, tons of .NET, Azure, you name it. And I'm sure that to this day we're doing even more than this, right? So if there's anything that you sit out there and you say, I would really like to know more about this, I'm sure get in contact, and because I can almost guarantee that we have someone in the company who's touched upon it and who knows about it. With that being said, that's all I have today. We have a few questions, which is amazing, also from earlier in the talk, so we'll just quickly look at some of them and see what you guys have written. Anders asks, how much does your automated test service impact the climate? Good question. I'm gonna answer that. I have honestly no idea. But I in terms of automated test service, I think that if you are into continuous integration or continuous delivery, it's definitely for longer projects gonna benefit you, or simply just making sure that if that your many projects set up or many people set up so that you cannot commit to Git repo if your statical code analysis fails, or if the unit test fails. I think that's a great way of doing it, or not commit, but if you can't merge. Let's see, go a little bit further. After the presentation, the slides, I'm not sure how we can share the slides, Michael, but the presentation will definitely be up on YouTube, so you can go them through again. En graf for vores productivity. No, Anders asked if the graph I showed earlier was for our productivity. No, that's what happens if you don't do clean code and you don't take your time writing proper code. Clean code is actually what we at Netcompany also teach each other internally on our seminars. So I appreciate the decent pronunciation of Dijkstra. Thank you very much. Will it not cause a ton of overhead if you wrap all functions like that? It's a good question, right? I personally don't believe so, because in the end, what we try to achieve is basically making small packages or small modules that we can reuse, right? And what I didn't do, everything I wrote was public, right? But in a perfect world, you would have a bunch of private functions which would simplify the logic, I think, and would make it more readable for those who actually need to go into that code. Whereas your public functions will simply just tell other programmers what is it that you can actually use this class for, right? So I think, of course, if every single line is a new function, it's gonna be quite crowded. But if you keep your classes small and you're good at keeping to that single responsibility pattern, which we did not cover today, but is in the solid principles, I think it'll do you a lot of good. And Pecunilia, I can't pronounce your name, sorry. Lots of small private methods that are only called once. It depends, right? Yes, you said you add here projects and solutions should also be small. Yes, of course. It is, yeah, it's what we covered as well. I agree with that. It's a good point. I'll add that for the future. Self-explaining code, definitely. What else do we have here? how do you come to a common understanding of these practices in your team? Very good question here. So of course, this is, I mean, we have a lot of suggestions here, and it's going to vary, of course, what is a best practice for some of these. Like, that could be a best practice in one language and different in another. What we do is we usually try to sit down before programming on a project. We actually sit down, we set up a certain guidelines, as we call it, an official document which states how we to write this code, right? Because of course, if half the people follow clean code principles and the other half doesn't, I mean, you're not going to get a good result from it, right? So get the team together in the beginning and get a clear understanding of this. Share your knowledge with each other. A great way to do that is also to do stuff like code review. Read each other's code before you decide that it's good, and talk about it, right? A lot of it is communication with your peers and sharing that knowledge. Is there a point where you have too many small functions? Again, it depends. I think if you divide it in an appropriate manner, you can do it. As I said, I wouldn't break it out into a function simply just to do it, right? Again, I said that in the conditions, for instance, in if and while statements, you should break that out. If it's completely clear what that does, if it's a simple check, right? There's no need to do that. But if there's any way that someone will look at it and have to look into it and think more than 2 seconds about what is it I'm checking here, I would consider making it into a separate function. Someone mentions deep learning. I don't know much about that, how that is difficult. Yeah, when results are unpredictable, makes sense, of course. And finally, Mark has asked, I have been out of the coding game for 3 years, only been reading code in my work. Do you have any suggestions to get back into coding, starting from basic C#? Whew, good question. I mean, there are tons of material online, of course, online courses you can take, and a ton of good books. Yeah, I think usually what I would suggest is find something that you're really passionate about, a project you really want to do that's appropriately small in the scale, and then work on that, and then do more like learning by doing approach, right? So if you're very interested in, for instance, setting up, I don't know, a single page application using React, then find some sort of project you want to do. Make sure it's small enough that you are not going to do 10% and say like, I'll never finish this, and then start going into it. With C#, make a .NET project, make a simple .NET project, a web application with a backend. And I mean, you can host things on Azure for, okay, maybe not quite cheap, but it is definitely possible. For C#, if you are interested in games, you could do something like Unity development. Gregers asks, would you consider early returns clean code, or is single point of return better? That's a very good question, which also people have different suggestions. So I'm gonna swap over here back to this. So I'm assuming what you would have is some sort of string. So we have a situation where we have a string called and then you do if true, and you do hello equals 2, 3, or else you do hello equals 1, and then you return hello. So the question here is, if we do clean code, this is one way of doing it, right? And I could of course add other else if 2 equals 3. I don't know, none of this actually makes sense, and hello is this number. The question is, would we actually have a variable that we're going to change throughout the code, or are we and return in the end, or would we simply just return it throughout the code, like this instead? I think it usually depends. We have a tendency, if we use the variable throughout the entire code, that we're not sure exactly where I changed and what happened, right? I think one of the beauty of using a return statement is that code further than that is not going to be executed. And what we would say, I would suggest, for instance, if you had something like a null check, in the beginning of your code, instead of doing some weird stuff and checking, I would definitely say that if you have an input that's null, in this current case I would return some sort of thing or throw an invalid input. It's called, let's throw one of these. Why not? That would definitely be a way to do it. I think if you have kind of those edge cases that you need to catch early on, do it quickly and then return. But otherwise, I've seen both things being done, and I think people have reasons to do both. Awesome. Again, yes, it's a very good question. I think it's a matter of like, it can depend. It can depend, which is an awful answer to a question. But again, what you've seen today is a large amount of information, which of course you shouldn't follow to the point. You should take that in, consider, and bring that into consideration whenever you have doubts about something or when you're thinking. Yes, input testing, for instance, if input is wrong, no need to have a large if block, right? In Grails, you would do something like input.validate, and you could say, right, you could do a quick validation. Then we have a question: does the book from Uncle Bob also cover stuff like test stops in TDD? I'll have to look that up quickly. I don't believe. You know what? Let's have a look here. Stopping should be in here. I cannot find anything in the. It's been a while since I read this mock object. That sounds like something we would look at. It talks a little bit about it. I wouldn't read this book if you wanted to know more about stopping and mocking in terms of tests. I would, however, if you like Java, go ahead and use Spock. It has amazing capabilities for mocking, and it's once you've used Spock once, you'll never think of JU. Well, it still runs in the JUnit in the end, but yeah, I think I wouldn't go for clean code for that. That's for sure. Yes, final question before I'll turn off for today. Mark asked, I worked a lot in Unity already, making games at Uni. Should that type of knowledge translate easily into the type of work you do at Netcompany? Type of knowledge. We do a lot of different things. In terms of programming, what matters is being able to sit down and understand something. I would say sit down and take into account like the environment, right? You cannot learn every single language on the planet, and it's better to, I would say, be able to sit down, analyze a problem, and figure out what is the right language to do this in, than to just go ahead and try in whatever language you're best at, right? So you have to be, of course, flexible, but in general, if you have the passion and the energy for coding, and similarly also like customer interaction and figuring out how to help people with their IT needs, I think that's going to be a good combination to start with, right? And again, we have a huge, we do a lot of internal education wise. So for instance, as I mentioned, clean code is something you would meet throughout your career at Netcompany, and we have people who know about pretty much everything. I first came to learn actually clean code early on due to a study group we simply made because we thought this was something that should be studied a bit quicker. Like should be studied more intensely, and which we shared on our project and had great success with. I think that was I think that would be all for today. Thank you all for tuning in. I should mention that at the end of the month we have a second tech talk coming up. We have our colleagues from the UK doing a talk on Microsoft Teams, especially in this period of time. It's nice to know how exactly to utilize that for its full potential. They're doing a masterclass on that. So if you have any interest in Teams or anything else, stick around and make sure you follow us on everything that can be followed to make sure you don't miss anything. And otherwise, I hope you've somewhat enjoyed the presentation today. I know it was very quick. If anything you need to redo, you can of course usually find like a brief summary. People write like cliff notes to the book, and you can go ahead and find that online, which will summarize maybe some of it. And otherwise, go find the book, buy it, and read it. It's a great read for, I would say, any programmer who wants to improve their quality of code. So thank you very much, all of you, for sticking around, and have a lovely evening. Bye.